Okay, good morning. I just decided to explain myself this time, what I'm doing. And maybe I've done it before, who knows. So I retired. Then I realized I'm bored. I'm bored stiff. So I decided that what did I always want to do besides I was in construction, but I always had an interest in mechanics. So I bought this 1976 Trans Am, piece of junk. It was rusted in somebody's backyard. The engine was frozen. It was rust everywhere. Anyway, I rebuilt that whole car. It took years. But then that was done. So I decided, what do I want to do now? So I bought a 64 Galaxie. It got towed over on one of those huge tow trucks that you see. They have like 10 cars on it. Well, it barely ran, and it didn't shift. The transmission was shot. I'm leading up to this video, and I'm walking around my yard. So I got the 64 Galaxie. It barely ran. It didn't shift. Automatic transmission. By the way, in 64, the 289 is different than other years. The C4 is called a 5-bolt. It bolts to the there's 5 holes in the back to bolt the C4. Anyway, I'm getting sidetracked again. I might elaborate on that. But anyway, so I rebuilt the C4. But then I decided, the 289 was shot. I did a compression test, if I didn't say that. I put my hand in front of the camera. So I got this 302, but then I found out that the 302 is a 6-bolt bell housing. So then I had to go search for a bell housing. Basically, what I'm saying is, I'm retired. I like when you get a car, it kind of takes you on a path. It's like going to Disneyland. You don't know where you're going. So in this video, I built an engine run stand. I'm not a welder, I'm not an electrician, I'm not a mechanic. So I built an engine run stand, and again, I had to figure out where to get the metal, how to cut it, all that, how to weld it. But now I'm to the instrument panel. I think this is part 2 or 3 of the instrument panel. But now I wanted to, well, let me step back. I did fix cars and trucks my whole life, to save money. But they were always in a car, like let's say the engine. The engine was always in the car, where you just unhook the wire, you hook it back up, and there's no figuring out anything. But when you build a run stand, you have to understand how the starting system works, the charging system, how to hook up instruments. It's more complicated than you think. So my videos, they just kind of, like I think I said this, the car tells you what to do. You get in the car, it won't start. Well, it's telling you, fix me. The engine doesn't run right, the engine's saying, fix me. The lights don't work, that says, fix me. Well, same with the run stand. It's telling you, hey, I want some instruments. If you're going to build a run stand, I want to know what I am. What's wrong with me? Anyway, that's my logic. Then my lawnmower breaks down in the middle. I fix that. The thermostat housing is stripped. Trying to figure out how to test the instruments, where to get the instruments, where to get them cheap in case I blow them up. It's just I'm following the flow. It's just what I like to do, and there's millions of YouTube videos and people do the same thing, and I like watching them, and so I'm just sharing mine. Maybe somebody likes watching mine. Yeah, if you watch this video, this is going to be, I'm walking around my shop here. This is going to be part 2 of the instrument panels, hooking up the instrument panel for the run stand. And I don't know what I'm doing, but I'm figuring it out. But every time I do something, It helps me understand more, and that's part of retirement, having fun. It's frustrating, but it's fun. So I'm gonna have all kinds of figuring things out, making mistakes. I got a new gauge, motor meter off Amazon. RPM. I think it'll drop in that hole, but this type has a pretty cool thing. So it says 2, 3, 4, 5, 6, 8 cylinders, so you can set it to different cylinders. Let's see if it fits in here. I hope it does. Again, I bought the cheapest one. It would fit into this hole. I just want to explain a few things that I've learned. So first of all, this box here and with the blue and the black, that's my instrument panel that I built. Okay, here's the fuse box, the battery, oil pressure, and water temperature. So that's a gauge. So these indicate gauges, and that one in the center, this big one, is a tachometer. The rest of them are just regular gauges. And then there's a line right here, you see it? These are broken into 2 circuits. So the upper part is the light of the gauge, and the bottom part is the needle on the gauge. So I have all my lights on one circuit, and we're going to go backwards. So here's the end of the line. So it's the red wire, I got a wire coming over here, and so on. So then it goes into this, I'm going to show the fuse box up close. Again, I didn't know this for some reason, I just didn't know, so I'm explaining it. And then it goes through the fuse to this, there's like a metal strip in the back of this fuse box. There's a bunch of them, but I'm just showing you, here's 1, here's 2. So then it goes through the fuse, through this strip, back to the battery. And I'll try to show a close-up of this. I just never really understood it, but until now, or last couple days. Each of these gauges of these 6 have a red, a yellow, and a black. They all do if they have an electronic sensor. So we're just pretending like they all 6 have a sensor, even though I only have 2. So the way it works is the red, let's see if did I draw one? Well, anyway, the red is the power, which would be going to a fuse. The black is a ground. And the yellow is the hot wire. In other words, inside the gauge, it somehow powers across, goes through a resistor as if the pressure changes or the water temperature changes, and it goes back in ground. So again, this whole plate is a ground. When we go over here, there's that 4 plate there, and then these are the other end of the fuses. So this big wire coming in, I don't know if you can see it, but it's going down to the plate. And then the other end, those little nubs, are the wires coming up, see them? So that would be, so from the battery, into the plate, back out, to the gauges. That's where it comes back out, after it goes through the fuse. If it doesn't have a sensor, it's going to have 1 less wire. Okay, first of all, if you build an instrument panel, again, this is about an engine stand, build it square like a box. And the reason is, I can't just stand this up. It's a pain in the ass. And I can't spin it around. So it'd be nice to have a flat bottom where you could just spin it around. Anyway, that's the way it works. Yeah, I might build this thing all over again. I just don't like the way it's coming together. But anyway, I built the stand so I could turn it. Just drilled a hole through the standoff here. Look at all these freaking wires. Yeah, it's not a lot easier to turn around now. But anyway, if you build one of these, if you're watching me and you're thinking about building an engine stand and you want to build an instrument panel, build a box. And I'd say make it, you know, however many gauges you want, wide or tall. This is one of those things, if you build it, then, I mean, once you do it, then you realize what you don't want and what you do want. I think the way they beat this mess is, if you look at a wiring diagram, let's say this hot wire is coming up, and then it's going out. Let's say it's going out to whatever, lights, whatever. Then they tie it in, they splice it in the middle of the harness somewhere, like 4 or 5 splices. Let me see if I can find a wiring diagram. Now on this one, this is off the Trans Am, and I'm just going to assume that all reds are hot. So like here, 1, 2, 3, 4, there's 5 wires coming together. That's what I was saying. They came together somewhere not near the fuse box, not near the key. And here's another one. There's 1, 2, 3, 4, 5 wires coming together there. That's how they did it. I'm not sure how to make that kind of connection. I mean, without using a wire nut. But yeah, it helped that me building this. It helps what I did to understand this a lot more. Okay, it's the next day. I want to rebuild that, but I decided just to make it work. But anyway, I changed the wire size. So I'm going from fuse panel to the switch I put in, down to the battery side. So remember, the key is only for the ignition. So here's something weird. So you're supposed to push this to stop it. That turns all the lights on. So I guess that means there's 4 connections on here. 1, 2, 3, 4. Maybe if I switch these, I can check it with my voltmeter. But something's not right. It's got to be here. Okay, I got my voltmeter here. I got the negative hooked up to my ground. So the button's pushed in right now. So it should be off. But it's on. I have a feeling these need to switch. Again, there's no paperwork, so the way this switch comes off, you just turn this lever and it pops off. Like I say, there wasn't any paperwork, but I finally figured it out. One side is when the button's out, it's hot. The other side, when the button is in, it's hot. It works. So So this could be emergency stop for the ignition, but it's not. It's just for my gauges. Like I was saying, I think I said I need to have some kind of way to turn this stuff off. So I had that. So that's for the gauges, and the key is for the ignition. Well, let's see if the voltmeter works. Okay, so right now with engine not running, cold, it lights up and the voltmeter works. Yeah, one more piece of information. These connectors here on the existing were shot, but I tracked them down. You can go to Napa, ask for EC104. That's these connectors. Piece of trivia when you're trying to find parts. Yeah, up in my office, it's later on this same evening. I went to put my sensor in. This is a thermostat housing. This hole is stripped. It's aluminum, so I had to find one. So if you need one, Amazon, 29 bucks. Again, they sell a lot of different kinds, but I had moved my temperature sensor over to here, so I needed this. And I also needed some fuses. This was in my back pocket when I came up. But anyway, I got all these fuses, and I'll show you how much that was. Yeah, again, Amazon is the greatest place, but look at, I got tons of fuses, $13.90. $13.98 delivered to my door. I didn't have to drive. Yeah, one more thing. I'm going to eventually rebuild this instrument panel, make it square. Yeah, I just want to show you this. $11.99. So the way this works, as far as I can tell, is power. Oops, damn it. Power will come in from the battery and then out. So power into the fuse and then out to your whatever, your lights or your sensors. I don't really understand the ground. I don't know that I need it, but I guess if I have 6 gauges, then I have 6 grounds, and that would go, that right there would go to the engine. Oh, and it's got LEDs, but I think the LEDs only go on when the fuse is blown. I'd rather have it the other way, but that's the way that's going to be. Anyway, it was cheap. There's one more thing I bought. These are variable resistors. So that in the top there is a screw. You can change the resistance. So like on my gas gauge on my Trans Am, it's only reading 3/4 when it's full. I think I can adjust the resistor to match the gas with that screw. Something to play with. Yeah, it's the next day, and I was thinking about how to hook up the amp meter. I mean, I'm going to show you how I have it hooked up. So it runs from the power through the fuse, through the amp meter. So in other words, it's just breaking the power line. There's no negative at all. Okay, so the way I have the amp meter hooked up is a ground and a power. That's wrong. I'm not sure. I guess what I'm supposed to do is, get rid of the ground and then run the power back to the power. I mean, I think that's how it works. So that's what I'm going to do. And then the vacuum gauge is just going to run to a vacuum port. And then I hooked up I don't know if I showed this the other day. So remember, this has to be grounded. So I grounded this to the engine block, which goes back down to the battery eventually. And then the oil sending unit, I brought a wire up, and that's just going to go to oil pressure, which is this one, up to this wire. And then the water temperature, which I was talking about last night, which I had to take out the thermostat housing. That wire is going to run to the water temperature. To this lead. So again, I'm kind of talking to myself when I do this, but so that'll take care of the oil pressure, the amp meter, the voltmeter we know already works, the vacuum, and then I have the tach that I need to get the engine running to figure out how that works. And then I'm gonna have one extra one because this is oil temperature, which I don't have a place to put that. What is this? No, that's oil temperature. Anyway, you get the point. But besides that, this engine is ready to go. Oh, the other unknown for me is I'm not sure if that's gonna work, the alternator. I think this just goes to battery power, but I'm not sure. That's the only unknown I have there. But I think I've done okay. I built an engine stand, I didn't know what I was doing. I'm not a welder. Hooked up the ignition, didn't know how to do that. Put in a Chevy alternator, didn't know how to do that. Put in an HEI or H whatever. I can't think of the terminology. So, going at this tach, it says tach wire. I'm pretty sure that goes to again, we'll call it the sensing wire. Pretty sure that goes to that. I suggest anybody that watches my stuff, try building something that you've never built before with a bunch of unknowns. Eventually you'll solve it, but the only way to solve it is to start. And again, the fuel gauge, I think it works exactly the same. And I'm thinking of a way to check. I mean, I don't have one, but I should order one. Or do I? Yeah, I have one on that fuel gauge I have upstairs. But I got an extra fuel tank. I can just either fill it up with water or just hold the float and go up and down. I might fill it up with water. So that's what I'm gonna be doing in the upcoming videos. But before I stop, I think I'm going to redraw this to make it simple. I mean, this is a bunch of circuits all together. I'm just gonna make it into one circuit. Okay, so I'm just gonna draw this freehand. I haven't thought about it at all. We'll see if I know what I'm talking about. So we have, I'm just gonna use whatever color I have. Battery, plus, minus. Well, let's make this more simple. I mean, the way I think, anyway. So basically, the way power works is it just has to go like this. But in the middle, there has to be something. Electricity is a funny thing. So we're just going to draw one gauge. And if I remember correctly, let's see. There's 1, 2, 3. So plus, negative. I'm going to use 3 colors here. Okay, I'll do 4 colors. So we also have the engine block. And let's just say we have a key switch. A key, gauge, again, this is not the starting circuit, but the way this works is pretty simple. So the power goes to the key, you turn it on. I'm not going to draw a switch. Once it turns on, it sends power to the gauge. Again, the red is power. Oh, then we have we got a sensing unit, basically right here. So then the sensing unit goes into the gauge. It's got a resistor in here. Now, this is the funny part about electricity that I don't understand. So from here, it'll go, again, we're not using my plate, my gauge plate, but from here, it's going to ground, the ground has to go back to the negative, but the ground has to also go to here. And that's it. What confuses me about this is if I have more than one gauge, say I have 2, 3, 4. We're just talking about the ground now. So let's say there's 3 units here, 1, 2, 3, whatever kind of sending unit you have. And they're all going to have power going. So the ground is going to go back. Well, yeah, it goes that way, but it's going to go back to here, to here, to here. They all have to be grounded. What I don't understand is if they're all hooked together, how is this gauge working? It must be working. In other words, if this sensor is sending out one resistor reading, this one's sending out another resistor reading, this one's sending out another resistor reading, but all the grounds are hooked together, why don't they get mixed up? It must be that this wire here, because each one of these would have a separate hot. It must be that this wire is telling the gauge how to work. It's working backwards. I don't understand why that works that way, but it has to work that way. So to simplify this even further, this is how I think electricity works. It's just a circle. Electricity works in a loop. Draw the battery again. Plus, that makes more sense to me. So we got a battery, a key, and we have a gauge. So the power runs to the key, you turn the key, the power keeps going, power gets to the gauge, but it won't work unless there's a ground. So the ground goes here for one. And the sending unit with the resistor, which is the third wire, somehow it goes across. This is minus. This is minus. This is minus. So the power jumps across inside the gauge, goes to here, and returns. That's all the way electricity works. That's what you get for. I don't know. I just didn't know. It's starting to click all of a sudden. All you have is loops and things in between. And again, if you have more gauges, then you just have more wires. But it's just the same thing times however many things you need to light up. And when I start the engine, we'll see if it all works. Okay, I'm outside mowing the lawn and my lawnmower broke. So I'm going to start it up. I think the noise is right about there. So here we go. As soon as I turn on the blade. Anyway, I think it might be, there's a pulley right about there. There's like 3 pulleys that spin the 3 different blades, I think it is. Anyway, my engine stand looks cool. So it's right there. I guess the first thing I do is just get on my back and just see if something's loose in there. So let me try that. Okay, so this blade seems, well, it shouldn't spin. So, I mean, what good is a free, hear that? So I guess I'll try tightening it up. Okay, first thing, there's a cover. I was just looking under there. This pulley's tight, so that blade shouldn't be spinning. But let me try tightening the bolts. So that blade was definitely loose. I tightened up the nut and now it kind of locks in. So I'll lower it back down and turn it on and see if I fixed it. Okay, I'm back outside. I'm gonna start it. And what you do is you pull this up to engage the blade. So what I want to say about diagnosing things, it rolled fine, it drove fine. It only worked when the blade went on, so that made me think it had something to do with the blade. So here goes, start it. It works. So that's amazing. I thought that everything was broken. How that came loose, I don't know. But I stopped using it as soon as it started making that noise, so it wouldn't come any looser. But now I can go back to mowing the lawn. It's a huge lawn. It's like 200 or 300 feet that way. There and then up above. It takes At this time of year, it takes like 2.5 hours. Success, lawn mowed. Okay, I'm doing a little experiment here. I'm trying to understand how to hook up my amp meter. So I got a headlight. I put 2 nails in to hold, just to make this easier because I only have 2 hands. So I got 1 lead, or we'll call this power, going to the probably low beam or high beam, and we got a ground. I also have a voltmeter, amp meter. Let me turn it off. I'm going to turn this to amps, direct current. I have the black lead in the COM and the red lead in 10 amp. I'm taking the black power lead, so I have a hot and a red, and I'm going to the ground side. Let's see if I get this right. I still haven't quite. Okay, so now I'm taking the either side. I'm going to the positive side, I'm calling it. So now we have 1 lead out of the meter and the power lead. So the power is basically going to run through the meter if it works. So let's let it settle down. I think it has to do with heat as it gets warmer. But it's running right at about 30 milliamps. When I first started, watch it jump high for a second. I'm looking at the one on the far left. What is that jumping to? For 1 second, it took 3 amps. So anyway, that's the experiment. The experiment is to hook up an amp meter. So that's the amp meter on the engine stand. Okay, I just want to see if I could draw this to figure it out. Got an amp meter, and we got a bulb. So the ground, and this is the ground, this is the hot. We'll call this the ground and a hot. And we got 2 leads here. We'll call this the ground, and we'll call this the hot. So the battery ground is going to here to here. And again, these are the nails. Let's see what I do. So we got the bulb running to the hot nail, and the plus running to the hot, and the ground running to the plus. Again, that's plus. Yeah, that's how it is. Let's just draw this again. We've got a meter, 2 leads. We have a battery. I guess it doesn't seem right to me, but I guess it just hooks up like a light bulb. Negative to negative, Of course, there is no negative on the meter. See, the only thing I don't get about this drawing is, in this drawing, there's no load. There's no light bulb or anything. Will an ammeter work? I mean, even though if we have all the other systems, the ignition, does it have to run directly to the meter, or can it run, let's say, to the lights and then to the meter? In other words, if that was a light, could it run like this? If that makes any sense. The only way to find out, I guess, is to try it. If anybody follows what I'm thinking here. I could watch a bunch of videos, but I still wouldn't get it. I'm one of those people that I got to do it to get it. So earlier in the video, I showed that I was going to order this fuse box. I guess that's how you do it. So I got power coming in. Use the voltmeter. Put it on volts. See if put this back in voltage. The ground isn't connected to this. It's connected to these. So okay, that makes sense. So again, if I wanted to use an amp meter, I just put it in line here. This. Will it work not running through the light? Yeah, it does. So it should work the way I have it. If you can follow all that, it's just an experiment because I don't know what I'm doing, but I think the best place for the meter would be right in the line with the power going right to the fuse box. Which we did do, right? Let's do that one more time. We're interrupting, we're interrupting the power in. Yeah. Anyway, it does work. A 1 amp. This is a 1 amp fuse. See the light go on? That's what I was trying to do. That means the fuse blew. I don't understand why the light goes on. How can the light go on if there's no power? That's it. So this is a variable resistor. I think I showed a picture of it. I was going to order one. So I got the meters, the leads hooked up, and I got it on resistance. And right out of the package, it's 2.4. I've never used one of these before, so I'm turning it counterclockwise. So anyway, it works. I want to turn this again. It's got a little screw in the end. I'm turning it clockwise. It's a pretty interesting little thing. It's basically a baby dimmer switch. That's what it really is. Maybe I'll mess with the gas tank today. I don't know. I don't really feel like it. The maximum rated current of battery box is 100 amp. That's plenty for an old car. And the maximum 30 amp per circuit. So it means you could put 30 amp breakers in here. Yeah, I decided to play around with this fuel tank. And there's a sending unit right here. Anyway, the resistance should change as that. Let me see. It's full of rust. Let me see if I can figure out how to check the resistance. See if it works. Okay, I cleaned this. I cleaned that. I cleaned the spot here, and I cleaned the spot here. So first, let's see if this is even conducting down to there. I don't even have a tone. I mean, I got a lot of resistance. It's just shot. I'm gonna go grind this and break it loose. I want to see what's inside this. It's got a strip in there. It gets wider, then narrower. So I guess the wider, the more resistance. I'm slotting the ohm meter along that strip. Let's see. I'm starting at the narrowest. I just can't. 199 at the narrowest. I'll go to the highest. $262 at the thickest. This gas tank's no good, so I decided to cut it open. Here's what's left of the float, I guess. So we'll put all this stuff down to one end. It's no good. I mean, it's not really that bad. I don't see any pinholes or anything, but look at this junk. I just couldn't resist. I had to do it.